Alright everybody, this is section 7.2. We are once again going to talk about the law of sines, but it's going to be the ambiguous case. So in the first section we were given two angles every time, alright, and that allowed us to make one unique triangle each time. We didn't have to think about it, we just solved the triangles and there was nothing to do or any worries that happened. Now, what happens with the stuff we're going to do today is we are going to get two sides and one angle. And what's going to happen is once you take the sine inverse, way back in every chapter we've ever dealt with when we're taking sine inverses, is we have two options going around the circle each time. Remember, we had two different quadrants and things like that. So there's going to be a situation in which there could be one specific one, there could be two actual triangles we have to find, and there actually could be zero. That's the kind of problem that we have. So what are we kind of talking about here is you might be given this side and this side, okay, and you have the angle in between. And what we're going to kind of talk about is you might have an angle that closes a triangle off here, like this might be a side, okay, and you might have a very small angle, or you could have a side that closes off the triangle that way perhaps, okay, and you're going to end up making a very big angle, and these sides might be the same length depending upon what happens. So what I'm trying to get at is that there could be two different triangles. We just don't know how the triangle is actually set up, because the only thing we know is just two sides and an angle. Okay? Likewise, there might actually be no solution, because if you have a side that's too small for the angle that's given, it won't reach it and won't make a triangle. So it's just going to be some give and take, kind of guesstimation, following along and doing some things. Now, here's the deal. If you look at the next 4 slides in your notes, there are literally 400 different ways that we could think about or remember it, and a lot of you are looking at this like, oh my God, Wilson, you're going nuts. Okay, here's what I want you to do. I want you to cross it out. This one, you guys should like this. This one, just X them out. And you're going to be like, Wilson, you're killing paper. Okay, you're supposed to go green, right? Well, I don't care. Okay, cross them out. I don't want you to worry about, oh, what case is this? Which case is that? How am I supposed to do this? What am I supposed to do? I want you to look at an example. I want you to draw a picture, and I want you just to do the law of sines every time. Okay? I don't want you to worry about, oh my God, I have two sides, an angle this time, and I'm looking at, okay, this option or this option. I don't want us to worry about that. I want us to get into a pattern of doing what we're doing. Okay, so right now I know that I have an angle of 30 degrees, and I usually draw my triangle the same. It's not that it has to be exactly to scale. Alright, and I'm going to label them A, B, and C as my one I don't know. When I say solve each triangle, I do need to get every possible angle and every possible side. And what I do is I put in the information I know. I know angle A is 30 degrees. I know that side A, which has to be across from angle A, is 2. And I know that side B is 6. I have absolutely no information about C or side C at all. So the only option for me to do at this point is use the law of sines to try find angle B. Okay? And I just want you to set up the law of sines. We've done it for the last day. So sine B over its side, which is 6, equals sine of A, which is sine of 30, over 2. And I want you just to cross multiply. So that would be, change color here, 2 sine B equals 6 times the sine of 30 degrees. And to get B all alone, you got to divide by 2. And I want you guys to actually go through and get that number. And I believe sine of 30, I believe, is 1/2. So I'm going to say that sine of B equals half of 6 is 3 on top over 2. And if some of you are looking at that as 1.5, and then you take the sine inverse of both sides, because that's how you get your B all alone. And as long as you're in degree mode, your calculator better not like you. It should spit out an error. Okay? If you ever get this scenario, you set up your triangle, you end up going through all this work, and you end up getting an error on your calculator, that simply means that this triangle, given these pieces of information, is unsolvable. there's no way this can work. Okay? So you just say no solution. Not possible. Something, somehow, some way tell me that. Given this information, there's no angle B that can physically make this work is what it's saying. Okay? So that is the process of no triangle. So I'm trying to give you the good one first. Alright? Let's look at another example. Let's keep trying going through the process. Okay? So what I need to do here now is once again set up this triangle. So what am I given? Literally, I just draw a triangle. I don't really care if it looks good. Okay? I have a triangle KMN. That's the three letters I'm dealing with. So I just go KMN. Okay? K I'm given is 35 degrees. I'm given that little m. So where's little m? Side m. Side m would be down here, across from the 12. And then side k is 9.1. I know nothing about angle n, and I know nothing about little n. So what I need to do first is just go through and try set up and solve for the angle that I possibly can get. So angle m is the one that I'm going to look for. So I'm going to say sine of angle m divided by 12 is equal to sine of k I'm given both pieces of information of, so sine of 35 over 9.1. And now I'm going to cross multiply. So you guys, it's the law signs. You can go through this yourself. So 9.1 sine of m equals 12 times sine 35. And divide 9.1 out. And then actually take the sine inverse as well. Okay? So I'm just going to do this all at the same time. So m equals the sine inverse of this number in here. So 12 sine 35 divided by 9.1. And you should end up getting that m equals 49.1. So that is technically our option 1. So I did not get an error that time. I know now that this possibility is 49.1 degrees. Okay? Given that, I can solve this triangle. Now, here's what the ambiguous case is talking about. Is there another possible answer for this? Alright? So you guys remember back, where is sine positive? This answer is a positive number in here. Alright? You can go in this angle. Where else is sine positive? In quadrant 2. Okay? So our reference angle we just found was 49.1 degrees. Okay? What is the second quadrant answer possible? So 49.1 is there. We have the possibility of saying, okay, 49.1 degrees shy of 180. So 180 minus 49.1 puts us as, what is my possibility? 130.9. Is that a possible option with the angle measure that was given? What I'm trying to say is, could I also end up with a crazy triangle like this? Ooh, that's ugly. Okay? But let's say this is my K still. This is 35 degrees. Okay? Let's say this is M because it's crazy. Let's say this is N. I think that angle M also could be 130.9. Is that possible in this triangle? Is there an angle that you can still get and make it 180 degrees? And there is. So what you end up getting is two possible triangles. And that's what's probably going to freak some of you out right now, but that's the idea. Now when I end up giving you two possible triangles, you have to solve for both of them. That's what kind of sucks about this whole scenario. So let's just focus in on one of them. Let's go back to that first one, okay? And let's finish what we know or need to find, okay? If you know two of the angles, the third one just has to add up to 180. Okay? So I'm going to say that this is M1 for triangle 1. Angle N1 has to be 180 minus 49.1 and also minus 35. And that's equal to 95.9 degrees. So I know that that's equal to angle N for triangle 1. So this one's going to be 95.9 0.9 degrees. Now obviously that doesn't kind of look right. That should be a, more than 90, but just go with it. It's just the way it's going to be. Okay? And then the only other thing we need is side n. Okay? So for you to solve for side n, where's my work? I don't have my work. So we just got to set this up. So another color here. This gets crazy. This is why you guys really got to box your answers. So I know what's given. My k's were given to me. Okay? So I like using those because then I can't go wrong. So 35 sine 35 over 9.1 is equal to, all right, sine of 95.9 over little n of 1. Okay, that's side n of triangle 1. And if you cross multiply, n1 is going to equal, it's going to be 9.1 sine of 95.9 divided by this sine of 35. So I'm just doing all of the algebra at the same time. I hope you're okay with me doing that now. And n1 will end up being equal to 15.8. All right? So that's going to be side of n of triangle 1. And now this should work out. Longest angle or largest angle, longest side. Okay? Middle angle, middle side, smallest angle, smallest side. So that works out for me. All right? Now I'm going to try to do the same thing here. If I go back to that second triangle, remember I said 130.9 is an option. What has to be angle n then? So capital N of triangle 2 is equal to, it's going to be 180 minus 130.9 and minus 35. You should end up getting an angle that is equal to 14.1 degrees. Okay, so I know this is 14.1, and I like dumping them in just to know. So what's left over? I still know that side across from K, which is given, is 9.1. I know the side across from M is going to be 12, no matter what, even though it looks crazy big. Okay, what's going to be the last one? So this actually should be the smallest side, and you just got to go through and find it. So once again, I'm given both K's. So sine of 35 degrees over the 9.1 equals, I need to find little n. N of 2 is equal to sine of 14.1 degrees over n2. So once again, I'm going to just cross multiply. These two multiply together divided by that. I'm just going to do all the algebra at the same time. I'm hoping you guys are okay with me jumping to that conclusion. Divided by sine of 35. That's what n of 2 is equal to. So n of little 2 is equal to 3.9. And that should be by far the smallest side because it's by far the smallest angle. And it is in that case, so it works. So here's the case where, how do you know why there's 2? When you guys take that initial sine inverse, first of all, did it work? If, as long as you didn't get an error message, it for surely has one triangle. And then what you have to do to check if there's a second one is do your normal thing that we've done every single section before. Get that second angle. So in this case, it was 130.9. And just see if it'll work with the angle given. All right? As long as it does, we're good to go. All right? So here's another one. I think I actually have... Oh man, I have 3 more to do. I might actually skip some of them. Just to set this one up quickly, I just want to show you once again what happens with the no solution part. You could draw this triangle if you want. I'm given that this is angle A. Yikes. That's ugly. Okay, so this is A. This is 114 degrees. Side A is 21. Side B, let's say that's B, because this is angle B and maybe that's C, is going to be 32. Sine of angle B is what I want to find because that's the only thing I know. Over 32 equals sine of 114 degrees over 21. And when you guys cross multiply for this, sine B should equal 32 times sine of 114 divided by 21. Okay? And when you guys do this, sine B will equal 1.39. And when you guys do the sine inverse, once again, it doesn't work. You're going to get an error. So this one will be no solution once again. So the no solutions can happen that simple. Okay? Once you go through, the only way is no solution is the first time you try to do the law of sines. It just isn't going to work out for you. And that's just the way it's going to be. Okay? What I'm going to do is try number 4. Okay? Here's the last one that I'm going to look at. We have a triangle, what's given. So I'm just going to kind of draw this guy out. Alright, let's say this is A, B, C. The reason I want C is this is the one given, 47 degrees. Once again, your letters can move however they want. I'm just kind of randomly throwing things in here. If this is A, side A's got to go here. And I need to look for angle A first. So sine of angle A over 12 equals sine of 47 over 20. And when you guys cross multiply and take the sine inverse, I'm going to kind of jump big time to conclusion. A will equal sine inverse of, we would have what, 12 times sine of 47 on top over 20. And when you guys dump all that in your calculator, you're going to get that A equals 26 degrees. Okay? So does that work for sure? I know that A can equal 26 degrees. I easily can get a third angle and make it equal to 180. Well, what's my other option? If I know that my original sine was 26 degrees, sine is also positive here. Well, what option do I have from home base? My other option to use is 180 minus 26. And that's equal to 154 degrees. Is that an option for me? Can I use that? 154 plus the actual number that's given is already over 180 degrees. Okay? So we actually can't use the 154 at all. Okay? This means that there's only one triangle. So this is how one triangle happens. Okay? And then it's kind of sweet because as long as you can rule out the other triangle, this goes quick. What has to be my other angle for angle B? Well, 47 and 26, add that up and subtract from 180. I know B has to be 107. And then I just need to find side B. So sine of 107, I just found that, over B equals what was given both instances. I like using the C's in this case. So sine of 47 degrees over 20. Alright, cross multiply, see what you get. So B is going to equal 20 sine of 107 when I cross that way, divided by the sine of 47, and B ends up equaling 26.2 units. As long as I put that in there, okay, I should end up saying, alright, longest or biggest angle, longest side. Alright, smallest angle, smallest side, middle, middle. As long as that works out, you're good. So once again, in this case, once you found that second possibility, this time when you added them up, it was too large. It just couldn't work. Alright, I believe this one, once again, is another option for two triangles, or one triangle actually. So let's see, what do I have here? I know it's a little bit bigger than 90, so let's go like this. This is my C, 97 degrees. Alright, side C equals 45. And then angle A here maybe, and maybe this is B. And if I say side A is 39. Let's go through and let's find out what we have. So I'm going to find angle A first. So I'm going to say that sine of 97 degrees over 45 equals sine A over 39. And to solve for A, alright, so A equals the sine inverse of 39 times sine 97 all over 45. And if I take the sine inverse of that number, A is going to end up equaling 59.3 degrees. Alright, so I know that A has to be 59.3. Well, what is my other option? So I already know that one triangle is a possibility. I can get the third one. Well, if this is 59.7, the other option is going to be 180 minus that. Okay, so what is 180 minus 59.7? Well, 120, so it'll be 120.3 degrees. Well, if I have 120 and a 97, that's going to be like 200 degrees used already. I can't deal with that. I cannot get a triangle for it. So I'm only going to have one triangle this time. Because of that option, I can't use the 120. Okay, so I just need to finish it. I just need to solve. I need to find angle B. So how do I find angle B? Well, B is going to equal 180 minus the two angles I've already found. Okay, the 97 that was given and minus the 59.3 we calculated. So B is going to equal 23.7 degrees. So I know this is 23.7. And then to find your last side, side B, I'm going to use that. So sine of 23.7 over the side I want is equal to, use the information given. I've given C in both instances, so I'm going to go sine 97 over 45, cross multiply. So my B is going to end up equaling 45 sine 23.7 degrees, all divided by the sine of the 97 degrees. And if you calculate all that out on your calculator, B, or side B, will be 18.2. And as long as you dump it in on your thing correctly, alright, the longest or largest side should be with the longest angle with the longest side. The smallest angle with smallest middle. It works out for me. I can feel confident on that. So there's another option for a one triangle. And for the completion of your notes tomorrow, I want you to go through and do this particular problem for me and have it done for class. So I'm going to expect this done when you walk into the classroom. I'm going to check it and make sure it is done. And then we will continue to work on this assignment after that. So once again, please do this assignment for me to check in class, and I hope you all have a wonderful day.